Hey everyone, this is the Math Nexus, and today we are going to solve the exercise 1.4 for IGCSE and O-level advanced. And this exercise revolves around the concept of the modulus functions. So, what are modulus functions? Well, modulus is actually represented by a sign, like it's this sign, and inside this a number is given, and this sign is called a modulus. Let me remove the circle in case you think it's something else. No. This is a modulus. So, for example, we want to say the modulus of -4. We will say the modulus of -4 will be this. Simple. This is the modulus of negative. So, modulus is actually any number without a sign attached to it. And when there's a number, for example, 3, and there's no sign attached to it, what do we assume it to be? We assume it to be a positive number, nothing else. If there's no sign here, it's any haywire number, we are going to assume it as positive. We only assume any number as negative if it is given. Okay, -4, -5, it is given. That's why we are going to assume this. But any number which does not have a sign with it, we assume it as positive. So that's the thing, that modulus is actually a number without a sign attached. So meaning that whatever value we will put in a modulus, it will become positive. If we input -4 in it, it will give us 4 instead out. Yeah. If we input -0.66667, we will get in a modulus, we will get 0.667. That's the thing. It just makes a value positive. And as we go on through these chapters, we will know the basic applications of these in graphs and how they're useful here. So just let's stick to the basics right now. So in the exams, mostly the term absolute value, as written here, is used to represent a modulus function. So just remember this and keep this in your mind so that you may not be confused. Okay, now we get to know. Okay, now we get to know what a modulus is. But what is a reverse of a modulus? So if we reverse a modulus, we get two values. And what are those two values? They are a positive value and a negative value. Simple as that. For example, we have the modulus of 3x plus 2 is equals to k. In order to open this modulus, we will have two values of k, meaning 3x plus 2 is equals to k, or 3x plus 2 is equals to negative k. So that means whenever you want to reverse a modulus, open a modulus, we will need to get two values, positive and negative. This is because we do not know what was the initial value. This is because we don't know what was the initial value that made up the modulus of the modulus. So for example, we have 3. And if we say we don't know if it has been already put into a modulus, we don't know that it came out of -3 or positive 3. We already know the positive value because it has been gone through a modulus. So again, if you open a modulus, you get two values, negative and a positive. I just reverse those. Just do that. So okay, now that's the basic concepts actually that you will need to know for this exercise. Let's go to the questions so that we can further clarify our concepts. Okay, so question number 1 for exercise 1.4 says that the modulus of 3x minus 2 is equals to 10. Okay, now what we need here, we just open the modulus here. Exactly, 3x minus 2 is equals to 10, or 3x minus 2 is equals to minus 10. Two values again. We're opening a modulus, we get two values, a negative and a positive value. Now we just solve these two individually. 3x is equals to 10 plus 2, which is 12, or 3x is equals to minus 10 plus 2, which is minus 8. X is equals to 12 upon 3, or x is equals to minus 8 upon 3. Again, this can be solved. 3 1 3, 3 4 is 12. So x equals to 4, or x is equals to minus 8 upon 3. Now what we'll do, that makes this question little long, not much, but still hectic one. We input the values of x into the equation to check if they are correct or not. Again, 3 multiplied by minus 8 upon 3 minus 2 is equals to 10. So the first value, second value actually I have inputted first. So 3 and 3 will be cut down. Minus 8 is left along with minus 2. So minus 10 is equals to 10. And remember, these two values are equal because this minus 10 is in the modulus, as we have input the value of x from the question's equation. Okay, so this is, I know this is a minus 10, but still it's in a modulus, so it will become positive because it gives us a sign less value. Okay. And along with, we are going to input the second value of x, which says the modulus of 3 multiplied by 4 minus 2 is equals to 10. 3 4 is 12, minus 2 is equals to 10, and 10 in a modulus is equals to 10. Yes, that means both of our values are correct. So the final answer is x is equals to 4, comma x is equals to minus 8 upon 3. Similarly, we'll do question 2b, to x plus 9 in a modulus is equals to 5. So 2x plus 9 is equals to 5, or 2x plus 9 is equals to negative 5. Again, same concept has been applied. We are going to simplify this. To x is equals to 5, which goes here becomes minus 9. 5 minus 9 is 5 minus 9. It's equals to minus 4. Or 2x is equals to minus 5 minus 9, because 9 is going there. So minus 5 minus 9 is equals to minus 14. So now x is equals to 4 upon 2, negative 4 upon 2, which becomes 2, negative 2 actually. Or x is equals to minus 14 upon 2, which becomes 7, negative 7, sorry. So again, we have to check these values. Input the value in the questions equation. 2x plus 9, 2 multiplied by 2 is equals to negative 4, plus 9 is equals to 5. So the modulus of 5 is equals to 5. Obviously, this is a correct input value. So again, for the second type of output we are getting, minus 7 multiplied by 2 is minus 14, plus 9 is equals to 5. So again, minus 14 plus 9 is equals to negative 5 in a modulus is equals to 5. This is again correct, as modulus will turn the negative value into a signless value, which we assume as positive. So again, the two values of x are x is equals to negative 2 and x is equals to negative 7. Let me clear the board for part C. Okay, so on to part C. It says that 6 minus 5x in a modulus is equals to 2. Again, we are going to find the two possible values. 6 minus 5x is equals to positive 2, or 6 minus 5x is equals to negative 2. And then what we'll do is minus 5x is equals to 2 minus 6, or minus 5x is equals to minus 2 minus 6. And minus 5x is equals to minus 4, or minus 5x is equals to minus 8. Negative and negative will be cut down on both sides. We will get x equals to 4 upon 5, or x is equals to 8 upon 5. Now we will input this value into the question and then see if they are correct. So in a modulus, we will write 6 minus 5 multiplied by 4 upon 5 is equals to 2. 5 and 5 will be cancelled as they are multiplied. We will say that 6 minus 4 in a modulus is equals to 2. And modulus 2 is obviously equals to modulus 2. That means this value is correct as an input. The second value, we will say that 6 in a modulus, 6 minus 5 multiplied by 8 upon 5 is equals to 2. 5 and 5 will be cancelled. 6 minus 8 is equals to 2. And in a modulus, minus 2 is equals to 2. So this value is also correct, because this negative value is in a modulus, which will become positive again. So again, this will be positive 2 as a result. So which means that x is equals to 4 upon 5 and 8 upon 5. Okay, part D says that the modulus of x minus 1 upon 4 is equals to 6. So what we'll do again, two possible values, x minus 1 upon 4 is equals to 6, or x minus 1 upon 4 is equals to negative 6. A quick reminder that you cannot at all pull out this 4 and directly multiply it by 6 without opening the modulus, because that will make the question incorrect. You can't ignore the modulus anywhere. Okay, so what we'll do now is x minus 1 is equals to 4 multiplied by 6 is equals to 24, or x minus 1 is equals to minus 24. We will say that x is equals to 24 plus 1, which is 25, or x is equals to minus 24 plus 1 again, which will become negative 23. So we will input these values in the question. We have got 25 minus 1 divided by 4 is equals to 6 in the modulus. In 25 minus 4 is 24 divided by 4 is equals to 6, which is obviously equals to modulus of 6. So this value is correct as an input. The second value will say negative 23, negative 1 is equals to negative 24 divided by 4. This should be equals to 6. So 4 1s are 4, for 6 are 24. Negative 6 in a modulus is equals to 6, which is not correct. I'm just joking, it's correct. So yeah, we have two values, x is equals to What is that? 25 and negative 23. Let's erase this board for part E. Okay, part E says 2x plus 7 divided by 3 is equals to negative 1. Again, two possibilities: 2x plus 7 divided by 3 is equals to negative 1, or 2x plus 7 divided by 3 is equals to positive 1. We are going to simplify this. 2x plus 7 is equals to negative 3, or 2x plus 7 is equals to 3. So 2x plus 7, 2x is equals to positive minus 3, negative 7, or 2x is equals to 3 minus 7. X is equals to minus 3 minus 7 is minus 10 upon 2, or x is equals to 3 minus 7 is 5, 6, 7, no, 4 upon 2. And we'll simplify this. 2 ones are 2, 2 5s are 10, 2 ones are 2, 2 2s are 4. We have two values for x. We'll input this into the question again. And the thing that makes this question lengthy and tiring is that we have to check these values by inputting them into the question again so that they are not wrong. So, and this is, other than a safety check, it's important to do this because sometimes the answers may come out of this equation when we simplify them, but they may not fit with the question. So that's a problem. So to part F, we'll say 7. Sorry, not part F. We have to do this right now. I just forgot. Part E, we'll input the value. What's happening here? Let me see. Wait a second. Okay. So part E, we will input the values negative 5. So 2 multiplied by negative 5 plus 7 divided by 3 in a modulus should be equals to 1. So negative 10 plus 7 divided by 3 should be equals to 1 in a modulus. Negative 10 plus 7, what is it? It's negative 3 divided by 3 in a modulus is equals to 1, which is obviously equals to the modulus of 1, which is correct. Okay, for the second type of value, we are going to say that for E, 2 multiplied by minus 2 plus 7 divided by 3 in a modulus is equals to 1. So minus 4 plus 7 divided by 3 is equals to 1. Again, minus 4 plus 7 is negative 3 divided by 3 in a modulus is equals to 1. Negative 1 in a modulus is equals to 1, obviously. So this is a correct answer. And so we have two values of x. X is equals to negative 5 and x is equals to negative 2. Just check this out. I think I have done a mistake in this one. 2 to the 4 minus 4 plus 7 divided by 3 minus 4 plus 7 divided by 3. Oh yes, this is a positive 3 and this is a positive 1. So yeah, still the values are same. X is equals to negative 5 and x is equals to negative 2. Okay, let me raise the board for question number 1F. So for part F, we have 7 minus 2x on 2 in a modulus which is equals to 4. We have two possibilities to this. 7 minus 2x is equals to divided by 2 is equals to minus 4, or 7 minus 2x divided by 2 is equals to positive 4. And become is 7 minus 2x is equals to 8, or 7 minus 2x is equals to 8. And this is going to be a negative 8. So again, negative 2x is equals to negative 8 upon, negative 8, negative 7, or negative 2x is equals to 8 minus 7. So simplifying this further, minus 2x is equals to minus 15, or minus 2x is equals to 8 minus 7 is 1. So x is equals to, we'll cancel out the minus, not in this one. This is going to remain a negative. So x is equals to 15 upon 2, or x is equals to negative 1 upon 2. Again, we have two values. We will input these values so that we can see if they are correct. So the question is 7 minus 2x. So instead of x, we are going to write 15 upon 2. Divide this whole by 2. Wrap it in a modulus and make it equal to 4. 2 and 2 are cancelled out. 7 minus 15 is equals to negative 8 upon 2 in a modulus is equals to 4. 2 ones are 2. 2 fours are 8. Negative 4 in a modulus is equals to 4. This is correct. And the second part of the equation says 7 minus 2 minus 1 upon 2 and divided by 2 is equals to 4. 2 and 2 are cancelled, but 7 plus 1 will go on because minus multiplied by minus is equals to plus. So 7 plus 1 is equals to 8 divided by 2 is equals to 4. And obviously 8 divided by 2 is 4. So the modulus of 4 will become 4, which is quite correct. X is equals to negative 1 upon 2 and x is equals to 15 upon 2. Okay, part G says that x upon 4 minus 5 is equals to 1. So again, two possibilities: x upon 4 minus 5 is equals to negative 1, or x upon 4 minus 5 is equals to positive 1. X upon 4 is equals to negative 1 plus 5, which becomes positive 4, or x upon 4 is equals to 6. Let me erase this part. We can solve this question. Bear with me. It's going to be. Okay, this is enough, I guess. So we are going to say that x is equals to 4 4 is 16, or x is equals to 6 4 is 24. We have the two values of x. Again, we input these values. X upon 4, 16 upon 4 minus 5 in a modulus is equals to 1. 16 upon 4, 4 1 is 4, 4 4 is 16, 4 minus 5 is 1, negative 1 actually is equals to 1, but it is in a modulus, so this is the correct input. The second part, the second output of x we are getting is 24. So 24 divided by 4 minus 5 is equals to 1. 4 1 is 4, 6 4 is 24. 6 minus 5 is equals to positive 1 in a modulus is equals to 1, which is obviously correct. So x has two values, x equals to 16 and x equals to 24. These two inputs are correct for x. So now for part h, we are going to say that x plus 1 divided by 2 plus 2x upon 5 is equals to 4. Let's do this really carefully. X plus 1 divided by 2 plus 2x upon 5 is equals to 4, or x plus 1 divided by 2 plus 2x upon 5 is equals to negative 4. Similarly, we are going to say that x plus 1. So first of all, I just simplify that. We have to make this a 10 because we will take the factors of both of these, 5 and 2. So we'll get 5 1s are 5. Sorry. Okay. 5 1s are 5 and 2 1s are 2. Yeah, that's it. We multiply these two. 5 multiplied by 2 is equals to 10. So that's why we are going to take a common denominator of 10. To make 10, we have to multiply by 5. Thus, we will multiply the upper value by 5. The lower value will be multiplied by 2 in this case, and the upper will also be obviously multiplied by 2 because the denominator is, the numerator is going to follow the denominator. So x plus 1 multiplied by 5. So I'll just write directly right now. We have less space. 5x plus 5. 5x plus 5 is equals to 4. 5x plus 5 plus 4x is equals to 4, or 5x plus 5 plus 4x is equals to negative 4. Let me just clear check it again. 5x plus 5 plus 4x equals to negative 4. And it's all going to be divided by 10. We were just missing that. So obviously what we are going to do, 5x plus 5 plus 4x, I'll just simplify this in a minute, is equals to 40, or 5x plus 4x plus 5 is equals to negative 40. This taking too less space. So 5x plus 4x is equals to 9x, and 9x is equals to 40, and what we're just gonna minus it with 40 minus 5, yes, 40 minus 5, which becomes 35, or 9x is equals to, and what we are going to minus 40 minus 5, minus 45. Okay, we have minus 45 and 6. Okay. Now the next thing we are going to do, x equals to 35 upon 9, or x is equals to minus 45 upon 9. Just we are directly going to jump in the next step, in which we find out the values by, if they are correct, by inputting them into the question. So x plus 1, 35 upon 9 plus 1 divided by 2, all of this divided by 2, plus 2 multiplied by 35 upon 9 divided by 5 in a modulus should be equals to 4. So use a calculator. 35 upon 9 plus 1 divided by 2 is equals to 22 upon 9. Use a calculator for this. Don't need to be a mathematician right now who's like the greatest of all time. Use a calculator, it's better. If you have that facility, why not use it? So, and 2 multiplied by 35 upon 9 divided by 5 is equals to 14 upon 9. in a modulus is equals to 4. Just add these values again with the calculator and we will get 4 is equals to 4. Okay, so this is a correct input. So let me raise the space for the next solution, and we'll get again the second value was minus 45 upon 9, so minus 45 upon 9 in a modulus again divide by 2 plus 1 and plus, oh sorry, just remove this modulus, plus, let me erase this, plus 2 multiplied by again minus 45 upon 9 divided by 5 in a modulus should be equals to 4. So if we just solve this whole equation in the calculator, we will get 4. Just input this into the calculator, man. It's not in a hard pass rule. So the modulus of 4 x is actually negative 4. So the modulus of negative 4 is equals to 4, which is the correct output. Input. X is equals to thus x is equals to negative 45 upon 9 and x is equals to 35 upon 9. That's for part H. Let's erase some space so that we can solve part I. Okay, so part I says that 2x minus 5 in a modulus is equals to x. And this is a different type of question because we have x on the different side, but still it's the same thing. It's a little bit complicated, and I don't think it should be called complex. So 2x minus 5 is equals to negative x, or 2x minus 5 is equals to positive x. Two values out of a modulus again. So 2x plus x is equals to positive 5, or 2x minus x is equals to positive 5. So 3x is equals to 5, or x is equals to 5. Again, x is equals to 5 upon 3, or x is equals to 5. So now you will just input them into the question and we will get 2 multiplied by 5 upon 3 is equals to 10 upon 3 minus 5 is equals to 5 upon 3. That's simple. 10 upon 3 minus 5, again, use a calculator, makes life much more easier. So negative 5 upon 3 in a modulus should be equals to 5 upon 3, which is correct. So this input is correct. The second input says that x equals to 5. So 5 to the 10 minus 5 is equals to 5. So 10 minus 5 divided 5 in a modulus is equals to 5, which is again correct. So we have two values of x again, x equals to 5 and x equals to 5 upon 3. Thank you. That's for question 1. Okay, for question number 2, we have part A, which says that the modulus of 2x minus 5 divided by x plus 3 is equals to 8. Thus, we would say two possibilities again, 2x minus 5 upon x plus 3 is equals to negative 8, or 2x minus 5 divided by x plus 3 is equals to positive 8. You can multiply these, simplify it. 2x minus 5 is equals to negative 8. 8 3 is 24, negative 24, as this is plus minus minus, or 2x minus 5 is equals to 8x plus 24. Simplify. Sorry, I did not apply the x in. So 2x plus 8x is equals to 10x is equals to minus 24 plus 5. Or 2x minus 8x is equals to minus 6x is equals to 24 plus 5 is 29. So x is equals to minus 24 plus 5 is, what is minus 24 plus 5? Minus 19 upon 10, yes. Or x is equals to minus 29 upon 6. Simplify this. It's 29. In a modulus, 2 multiplied by minus 1.9 minus 5 divided by 1.9 plus 3, which is equal to 8. Input this into a calculator, we will get negative 8 in a modulus is equals to 8. And the second input is x equals to minus 29 upon 6. So 2 multiplied by 29 upon 6 minus 5 divided by 29 upon 6 plus 3 in a modulus should be equals to 8. So 2 1s are 2, 2 3s are 6, simplified here, 29 upon 3 minus 5 divided by 29 upon 6 plus 3. So which is equals to, input this into a calculator, it is equals to a modulus of 8 is equals to 8, which is obviously correct. So we again have two values of x. X is equals to minus 29 upon 6, or x is equals to minus 19 upon 10. We have two values of x, we can say this is minus 1.9 also. So where is this all? Second part. Part 2b tells us the modulus of 3x plus 2 divided by x plus 1 is equals to 2. So what we'll do again, two possibilities. We have 3x plus 2 divided by x plus 1 is equals to positive 2, or 3x plus 2 divided by x plus 1 is equals to negative 2. Simplify each of these and we will get 3x plus 2 is equals to 2 to the 4 x plus 2, or 3x plus 2 is equals to negative 2x negative 2. So simplify these. 3x minus 4x is equals to, you just get these two and 0, or 3x plus 2x is equals to minus 4. So 3x minus 4x, we'll just say x is equals to 0, okay? Because the negative value of x will not affect it. It's going to be divided here. It will become 0. So x is equals to 0. Or 3x plus 2x is equals to 5x is equals to minus 4. And x is equals to minus 4 upon 5. So we have two values of x again. What we'll do now, we input these values into the question again. So the modulus of 3 multiplied by 0 plus 2 divided by 1 is equals to 2. Should be 3 0 0. 2 divided by 1 is 2. So this is correct. And what we'll say for the second input, we have e multiplied by negative 4 upon 5 plus 2 divided by negative 4 upon 5 plus 1, which should be equals to 2. And if we just multiply these, input this into a calculator, we will get the modulus of negative 2 is equals to 2. So this is the correct answer again. For the third part C, we have a modulus of 1 plus x plus 12 upon x plus 4 is equals to 3. Input the values, we will get two different values, positive and negative. X plus 12 divided by x plus 4 is equals to 3, or 1 plus x plus 12 upon x plus 4 is equals to negative 3. So a mistake that most people do is directly multiply 3 with x plus 4. But no, you should first take the LCM, as this one does not have a denominator of x plus 4. So it's important for all of these to have a denominator of x plus 4 for it to be multiplied on the other side. So not right now. We'll say 1 multiplied by x plus 4. Again, LCM will be taken. X plus 4 plus x plus 12 divided by x plus 4 is equals to 3, or x plus 4 plus 12 plus x divided by 4 x plus 4 is equals to negative 3. You know what? Just leave this for here. We will simplify this later. Just do one thing first. You will say that x plus x equals to 2x and 4 plus 12 is equals to 16. 2x plus 16 divided by 8 is equals to 3x plus 4. 3x plus 4 in a bracket. You get 2x plus 16 is equals to 3 multiplied by x equals 3x. The second we are going to multiply by 3 multiplied by 4, which is 12. 3x plus 12. And we will get 2x minus 3x is equals to 12 minus 16. So again, minus x should be equals to minus 4, and the negative values will be cut off. X is equals to 4. We have one value of x which is equals to 4. Now let me erase this part so that we can do the second may be value. That's why I always erase the line. Yeah. So we have one value of x. So the second we just left here, we will just copy it here. X plus 4 plus 12 plus x is equals to negative 3 multiplied by x plus 4. Okay. So you'll say that plus 4 plus 12 is 16, and x plus x equals to 2x. 2x plus 16 is equals to negative 3x minus 12. So just simplify these values. 2x plus 3x is equals to minus 12 minus 16. 5x should be equals to 6, 7, 8, 20, negative 28. X should be equals to negative 28 upon 5. We have the two values. We may need for the rest of the question, but still we have to find if these values are correct by inputting them into the question. So C part is 1 plus minus 28 upon 5 plus 12 divided by minus 28 upon 5 plus 4 should be equals to 3. So if we just simplify this, we will get, in a calculator obviously, we will get so we will get, in a modulus we have negative 3, which is equals to 3 in return. So this is the correct thing. Again, for the second value, we will input x equals to 4. 1 plus 4 plus 12 divided by 4 plus 4 is equals to 3. Let's do this really quickly. 4 plus 12 is 16. 1 plus 16 divided by 8 is equals to 3. 8 1 is 8, 8 2 is 16. So 1 plus 3 should be equals to, 1 plus 2. 1 plus 2 is equals to 3. So 3 is equals to 3. This is correct. We have two values of x. X is equals to 4 or x is equals to negative 28 upon 5. Okay, for part D, we have inner modulus 3x minus 5, inner modulus is equals to x plus 2. So again, two values positive and negative. If we are going to reverse this process, 3x minus 5 is equals to negative x minus 2, or 3x minus 5 is equals to x plus 2. Exact same. So 3x minus 5, sorry, wait a second. So 3x plus x is equals to 5 minus 2, or 3x minus x is equals to 5, 6, 7. Okay, or x should be equals to 4 or 3, or 2x is equals to 7. X is equals to 3 upon 4, or x is equals to 7 upon 2. You have these two values. Input these into the question to check if they are right or wrong. So again, what we'll do is inner modulus, we will say 3 multiplied by 3 upon 4 minus 5 inner modulus is equals to x plus 2. So 3 is a 9, 9 upon 4 minus 5 is equals to minus 11 upon 4. Minus 11 upon 4 inner modulus is equals to x plus 2. What was x? 3 upon 4 plus 2 is equals to 11 upon 4. So our answer is correct. This input is correct. The second input 7 upon 2 is part D. 3 multiplied by 7 upon 2 minus 5 is equals to 7 upon 2 plus 2. 7 3 is 21. 21 divided by 2 minus 5 is equals to 11 upon 2. And the other side is also equals to 11 upon 2. This is correct. So for part E, we have x plus inner modulus x minus 5 is equals to 8. First of all, just simplify the question. Inner modulus, we have x minus 5, which should be equals to 8 minus x. So two values again, x minus 5 is equals to 8 minus x, or x minus 5 is equals to minus 8 plus x, because we multiply 8 by minus. Simplify this. Positive x, 2x is equals to 8 plus 5 is 13. Yes. So, or x and x will be cancelled out. And this is basically, if you see here, minus 5 minus 8 is not equals to 0. So this is a correct equation. We will say that this is not applicable. Okay, so it's incorrect here. And if we go on to just this single 2x is equals to 13, we say x is equals to 13 upon 2. Okay, and when it's 13 upon 2, we again input this value into the question. We say that 13 upon 2 plus inner modulus 13 upon 2 plus minus 5 is equals to 8. And if we input this into the calculator, we get 13 upon 2 plus modulus 13 upon 2 minus 5. 13 upon 2 minus 5. We have 3 upon 2 is equals to 8. Again, 13 upon 2 plus 3 upon 2 is equals to 8. So 8 is equals to 8. So that's the thing. This is the correct answer. However, we have only one value of x, which is 13 upon 2, or you can say 6.5. Okay, for part F, let's clear some space. And we can solve it easily. This. I think this much space is wide enough. Okay. And now what we're going to do is part F. It's 9 minus 1 minus x in a modulus is equals to 2x. First of all, whatever you do in a question, simplify the equation itself. So we have in a modulus 1 minus x is equals to 2x minus 9. And this is a negative 1 minus x. See? So for it to become positive, we have to change the other side. So in a modulus 1 minus x is equals to 9 plus 2x. 9 minus 2x. My bad. So we have multiplied this by negative. So now we will see the two possibilities. 1 minus x in a modulus is equals to 9 minus 2x. Oh, sorry, not in a modulus. And we are going to say that is equals to 9 minus 2x, or 1 minus x is equals to minus 9 plus 2x. Okay, so simplify this. Minus 2x will become plus 2x when it's come here. X is equals to 9 minus 1, 8, or negative 1, negative x. So it will become negative 3x is equals to, when this goes here, minus 10. cut these values of x equals to 8 or x equals to 10 upon 3. We have the two values of x. Now we will input these into the question again, and we have got 9 minus 1 minus 8 is equals to 7 is equals to 2 multiplied by 8. So we say 9 minus 7 is equals to 16. That at all is not the case. So this is cancelled out. If you just want to simplify this, this is 2 is not equals to 16. So that means the value 8 as an input is not correct. And 8. This is the cross. Okay. The second value if we input it, let's see if it's correct or not. 9 minus 1 minus 10 upon 3 in a modulus is equals to 2 multiplied by 10 upon 3. So 9 minus 1 minus 10 upon 3 is equals to 20 upon 3. And if we just see here that this all should be equals to, the other side of the equation should be equals to 20 upon 3. So this is equals to 20 upon 3 is equals to 20 upon 3. Both the values are same. Thus, our answer is correct for this output. So we will say that x equals to 10 upon 3 is the only and only correct value of x. And if you want to write this in points form, it's 3.334. Just round it off. That's approximately that. Okay, that's for question number 2. Let's do question number 3. Okay, for question number 3, A, we have in a modulus x squared minus 1 should be equals to 3. Solve this and we will get x squared minus 1 is equals to 3 or x squared minus 1 is equals to negative 3. Okay, and then what we'll do is x squared is equals to 3 plus 1, which is 4, or x squared is equals to minus 2. So now just look at it really carefully. If we say x is equals to under root 4 or x is equals to under root minus 2, most of you should know that if we put under root on a negative value, we get a math error. So this value is not applicable at all. This is a math error. So this can't be used. It is not following the rules of mathematics. Okay. This value will give us two values. How? I told you in the previous part that plus minus 2 will come out of this because I've explained the previous parts. We do not know how a square is formed. 4 squared is equals to 16, but minus 4 squared is also is equals to 16. So we do not know what made that 16, minus 4 or 4. That's why whenever we open an under root, we take two values, plus and minus. Okay, that's a little explanation. Okay, going on to solve this question, we take the inputs according to the question. So again, what we do is x, we have two values now, x equals to 2 and negative 2. So for the two inputs, we say x squared minus 1, 2 squared minus 1 is 4 minus 1 in a modulus should be equals to 3, which is correct. The other one, we have negative 2 minus squared, again 4 minus 1 in a modulus is equals to 3, which is correct again. So we have two values of x, x is equals to 2 and x is equals to negative 2. That is the correct values. So part B is similarly, I think the same actually. This is minus plus. X squared plus 1 in a modulus is equals to 10. And when we say that x squared plus 1 is equals to 10 or x squared plus 1 is equals to negative 10. It's really glitchy. X squared is equals to 10 minus 1 is 9 or x squared is equals to minus 10 minus 1 is equals to 11 equals to minus 11. Again, if we just put an under root here, x is equals to under root 9, we get or x is equals to under root negative 11. This is again not applicable. Okay. X is equals to plus or minus 3. So we are going to input these values into the question itself and see if they are correct. Plus minus 3. So what we do is x squared. Again, the answer will be the same for plus and minus 3 because it's a square. So I'll just solve it one time because minus 3 squared and positive 3 squared will become the same value. So no need to do it two times. Minus 3 squared or positive 3 squared is equals to 9 plus 1 is equals to 10 in the modulus, which is, yes, it's equals to 10. Okay, so that's for the question A. Let's proceed on to part C. Okay, so for part C, we have 4 minus x squared in a modulus is equals to 2 minus x. And what will that become? Again, we have two possibilities. 4 minus x squared is equals to 2 minus x, or slash slash is equals to minus 2 plus x. And for the time being, we're just gonna ignore this so that we can solve this later on. Just stick to one solution at this time. X squared minus 4 plus 2 minus x is equals to 0. Okay, so we have x squared minus x minus 2 is equals to 0. So just input these values into the calculator. It's like if you're using a Casio normal calculator, it's mode setup 5 for equation and 3 for a quadratic equation, and just input these values 1, -1 and -2. So 2 and -1. And if you are confused still, don't worry, I will make a video on the chapter of quadratic equations, but for the time being, just go on with the calculator. And if you are unclear how to get the quadratic equation on a calculator, search for it on YouTube. There's thousands of videos for that. X is equals to 2 or -1. Okay, you have two values of x. Now this or part, or 4 minus x squared is equals to -2 plus x. And what we'll do now, again, x squared minus 4 minus 2 plus x squared plus x minus 6 is equals to 0. Okay, and what we'll do now is again input these values into the calculator. 1, and the reason why I'm inputting 1 is because there's nothing, so we assume the coefficient to be 1. 1 plus 1 minus 6. If we get x is equals to 2, or x is equals to -3. We have two values here, and x is equals to 2, -3 and -1. So we have three values for x for which we have to check out. Let me erase this board. Okay, for part C's proving, we have to first say in a modulus 4 minus 2 squared is equals to 4. So is equals to 2 minus 2. So again, this will become a modulus of 0 is equals to 0, which is correct. Okay. For the second input, we have -3. So again, the negative value does not affect the final answer in a squared. So 4 minus x squared is 9. So 4 minus 9 is equals to 2 minus -3. So be careful to make a plus here. It's multiplying here. 4 minus 9 is equals to 5 in a modulus, but it's -5 is equals to 2 plus 3 is equals to 5. So this is also a correct value, and -1. So 4 minus 1 in a modulus should be equals to 2 minus 1. So that, 2 plus 1, because it's -1. So 4 minus 1 is 3 in a modulus is equals to 3. And that is correct. So we have three values of x, which are 2, -3 and -1. Okay, let me erase this part C so that we can proceed. And that's it. D, in a modulus, we will say x squared minus 5x is equals to x. So we will be ending with, again, two possibilities. X squared minus 5x is equals to x, or x squared minus 5x is equals to -x. And please wait, my alarms. So x squared minus x minus 5x is equals to 0, or x squared minus plus x minus 5x is equals to 0. And we were about to forget, but x squared minus 6x is equals to 0, or x squared minus 4x is equals to 0. But still, it is a quadratic equation because instead of an integer, we are writing plus 0. So still, it's a quadratic equation, and we can input it into the calculator. And instead of the integer which is not multiplied by x in any form, we can simply write 0 in the calculator. So that will give us, in this case, x is equals to 6 and 0, or x is equals to 4 and 0. Okay, and if you just solve this, again, input the values into the question. The question is x squared 6 is 36 minus 5 multiplied by 6 is equals to 30 is equals to 6. So as you can see, 6 in a modulus is equals to 6, which is correct. The first value, this one is correct. And again, if you just input 0, 0 squared is 0 minus 0 is equals to 0. Yeah, it's 0 everywhere. So 0 is correct. And last value we have is x equals to 4, and 0 is a common value, so we won't input it again. So x is equals to 4. For that, we are going to say that 4 is a 16 minus 20 in a modulus is equals to 4 Again, 16 minus 20 is equal to negative 4 and a modulus is equal to 4, which is again correct. So we have three values of x. X is equal to 6, 0, and 4. And all of these are correct. On to part E, we have x squared minus 4 is equal to x plus 2. Okay, inputting these values, x squared minus 4 is equal to minus x minus 2, or x squared minus 4 is equal to x plus 2 as it is. Okay, simplify both of these. X squared plus x minus 4 plus 2 is minus 2, or is equal to 0 actually, or x squared minus x minus 4 minus 2 is minus 6 is equal to 0. Again, input these values into the calculator and we will get x is equal to 1 and negative 2, or x is equal to 2 and negative 3. Okay, so we have now 4 values for x and we are going to input all of these into the question itself. Okay, what we have in the question, first of all, we'll take the value of 1. 1 squared is 1 minus 4 is equal to 1 plus 2. So 1 minus 4 is equal to 1 plus 2, which will go on to say that 1 minus 4 is negative 3 is equal to 3. So this is correct. 1 is a correct input. For negative 2, we have 2 squared is 4 minus 4 and is equal to negative 2 plus 2. 0 is equal to 0. So this value, negative 2, is also correct. And third value we have is again 2. 2 to the 4 minus 4 is equal to 2 plus 2. So there's let me see, yes, so 0 is not equal to 4. So that means the value positive 2 is incorrect. Positive 2 is incorrect. Cancel out this with. And that's why I really emphasize that 2 checks, 2 checks, 2 checks. They are the part of the question and the question is not completed without them. So be careful here. Okay, so the third and the last, fourth value of part E is 3. So negative 3, 3 is a 9 minus 4 should be equals to negative 3 plus 2. So we have 9 minus 4 is negative 5 and positive 5, sorry. It's positive 5 minus 3 plus 2 is equals to, well, it's, sorry, my bad, but this was positive 3 and this was negative 2. And we with a problem in the inputting of the quadratic equation, so that's why our value were coming wrong. But still, again, another excuse to show and prove that the wrong values will be proved wrong later on. And again, it's an emphasis on the checks. They are really helpful. So again, negative 3 was not going good with us. We're going to erase this and now try on with positive 3, and I hope that's the correct thing. Okay, so we have 9 minus 4 is equals to 3 plus 2, which is equals to 5 in a modulus is equals to 5. So again, this is the correct value, and we have 3 total values. X is equals to 1, negative 2, and positive 3. Okay, 3 values of x. On to part F. Okay, so part F, we have x squared minus 3 in a modulus, which should be equals to x plus 3. So again, what we'll do is, excuse me, 2 possibilities again. X squared minus 3 is equals to negative x negative 3, or x squared minus 3 is equals to x plus 3 as it was in fact. So simplify this, x squared plus x and minus 3 is going to be cut down, is equals to 0, or x squared minus x is minus 3 minus 3 is minus 6 is equals to 0. Again, input these values into the calculator and we are going to get that, wait a second. For this case, we have x equals to 3 and minus 2. For that case, we have x equals to negative 1 and x is equals to 0. So again, input these values and check out if they are correct value. And minus 1 squared is 1. 1 minus 3 in a modulus should be equals to 1 plus 3. So, sorry, negative 1 plus 3. And 1 minus 3 is 2. Negative 2 is equals to negative 1 plus 3 is positive 2. So again, this is correct. 1 is correct. Negative 1 is correct. X is equals to 0. We input it. We get 0 minus 3 is equals to 0 plus 3, and which is obviously a correct value. Again, is equals to 3. So 0 is also correct, and we have 3 and -2. Input these values again. 3 3s are 9. 9 minus 3 is equals to 3 plus 3. And we will get 6 is equals to 6, which is correct. So 3 is the correct value. Last value is -2. 2 to the 4. 4 minus 3 is equals to -2 plus 3. And 4 minus 3 is 1. So -2 plus 3 is also 1. So this is the correct value again. So we have 3 values for x for part F. We have 4 values in fact, -1, 0, 3, and -2. So these are the 4 values. On part G, we have in a modulus 2x squared plus 1 is equals to 3x. In two possibilities, we have a negative value if you open it and a positive value. So all 2x squared plus 1 is equals to -3x. Okay, 2x squared minus 3x plus 1 is equals to 0, or 2x squared plus 3x plus 1 is equals to 0. Just directly input these values into the calculator and we will get the answers. For easiness, I'll just put it here. We will get, in this case, we will get x is equals to 1 and x is equals to 0.5. 0.5. Okay. And the other thing, for the other case, we will get x is equals to 0.28 and x is equals to -1.7. Okay, now so we are going to input these values into the question itself. So starting from 0.28, we will say 2 multiplied by 0.28 squared is equals to 0.0784. Multiply it by 2, we will get 0.1568. Add it with 1, do it in the calculator, it makes life easier. So we will have in a modulus 1.1568 should be equals to 0.28 multiplied by 3, 0.28 multiplied by 3, which is 0.84. So that means they are not equal, and 0.28 is an incorrect value. So for the second input, we have -1.7, and what we'll do here is, okay, -1.7 will become 1.7 squared, 2.89 multiplied by 2 and added by 1, we will have 6.78 in a modulus. 6.78 in a modulus should be equals to 3 multiplied by -1.7. Obviously, -1.7 will give up a negative value, which is -5.1, and it is incorrect. So cross. Now x is equals to 1. So 2 1s are 2 plus 1 is 3. 3 is equals to 3. So that is the correct, and 1 is the correct input. And for 0.5 squared should be equals to 0.25. Multiplied by 2, we have 0.5 again, and added with 1, we have 1.5 in a modulus. So 1.5 in a modulus should be equals to 3 multiplied by 0.5 is equals to 1.5. So they are correct. X is equals to 0.5 and x is equals to 1 is the correct answer for this. Okay, for part H, we have 2x squared minus 3x is equals to, in a modulus, is equal to 4 minus x. So we are going to simplify this. Again, two possibilities. 2x squared minus 3x is equals to -4 plus x, or just leave it and we will do it later on. So first solve this one. 2x squared minus 3x minus x is equals to 4x plus 4 is equals to 0. Or now we can take the second value, which says that 2x squared minus 3x is equals to 4 minus x. So this will remain the same. 2x squared minus 4x plus 4 is equals to 0, or 2x squared minus x minus plus x minus 3x. So 2x squared plus x minus 3x is equals to minus 2x minus 4 is equals to 0. Just directly input this value. No need to simplify it. I know this value can be factorized. Just input this into the calculator. If you have done that manually, I would have recommended that, but not right now. So this one can also be factorized manually. So for this one, we have x is equals to 1 plus iota and x is equals to 1 minus iota. And iota has not been in the syllabus right now. So just right now ignore it. It's and I've already tested it. It's not the correct value. Iota are going to be wrong in this question. So this value is not correct. Okay, so don't need to worry. Don't be haywire. Where did that iota come from? It's not in the syllabus right now. So For the second part, however, we have interesting results. X is equals to 2 and x is equals to -1. Okay. And what we'll do now, right now is input these values. Okay. So 2 multiplied by 2, sorry, 2 squared is equals to 4. 4 multiplied by 2 is equals to 8 minus 8 from 3 multiplied by 2, which is 6. 6. We have 2 in a modulus should be equals to 4 minus 2, which is 2. Yeah, correct. 2 is correct. And again, for the second value, -1. So it's going to be 2 plus 3 is equals to 4 plus 1. So 3 for 5 in a modulus is equals to 5. So this is again a correct value. -1 is also right. So we have two values for x, which are 2 and -1. Okay. And on to part I, we have x squared minus 7x plus 6 is equals to 6 minus 6. Okay. Now, again, open this up. X squared minus 7x plus 6 is equals to 6 minus x, or x squared minus 7x plus 6 is equals to minus 6 plus x. Okay, so now simplify this again. X squared minus 7x plus x is equals to minus 6x, and we have cut down the 6 is equals to 0. Or x squared minus 7x. Why did I include the modulus here? I don't know why. And yeah, so x squared minus 7x plus 6 is equals to minus x, and plus 6 minus 6 minus 6 is equals to minus 12. It's equals to 0. Again, just input these values directly into the calculator, and we are going to get the values. X is equals to 6 and 0, or x is equals to 6 and 2. We have three values. Input these three values quickly, and what we'll get in return, use the calculator. So 6 is 36, minus 7 multiplied by 6, which is 7 multiplied by 6, and minus it and add it with 6. We have got 0. So in a modulus, if we have 0, other side should have 6 minus 6. Yep. And 0 is equals to 0. This is correct. 6 is the correct input. For the second input, we have 0 itself. 0 minus 0 plus 6. So it's 6 minus is equals to 6. Yep. Minus 0, well, it's the same. So 0 is the correct input. For the third input, we have 2. And what we are going to say is 2 squared is equals to 4. 4, 7, 2 is 14. 4 minus 14 plus 6 is equals to minus 4. So in -4 is equals to 6 minus x, which says, sorry, my calculator went down, 6 minus 2, which is 4. So this is also correct. 2 is also correct. We have three inputs right now for x. X is equals to 6, 0, and 2. These are the correct input, and that's for question number 3. Let's go on to question number 4. Okay, for question number 4, part A, we have two values. Y is equals to x plus 4, y is equals to x squared minus 16, but it is in our modulus. So first of all, we have the value of x, but we are going to simplify the second value. So for that, we are going to get y is equals to x squared minus 16, or y is equals to minus y is equals to x squared minus 16. And obviously, we do not want it to be a minus y. We just want it to be a y. So y is equal to x squared minus 16. This one is a perfect value. We do not want to change this. However, we are going to remove the minus value from the other one. So y is equals to 16 minus x squared. That's it. Now what we'll do is input the second value into it and see if the answers are correct or not. So x plus 4. That again, that's the concept of simultaneous equation. We mark this as 1, and we mark this as 2, and this as 3. So put equation number 1 into equation number 2. So instead of y, we are going to write x plus 4 is equals to x squared minus 16. And what we'll do now is x squared minus x minus 20 is equals to 0. Okay. And again, solve this directly. X is equals to 5, or x is equals to, and x is equals to minus 4. And for the second thing, or we are going to say put equation 1 to equation number 3. Okay, so what it will become is x plus 4 is equals to, what's equation 3? 16 minus x squared. Okay, 16 minus x squared, it will become x squared plus x minus 12 is equals to 0. Okay, and then just input this into a calculator again. X is equals to 3 and x is equals to negative 4. So we have three values for x. Again, x is equals to 5, 3 and negative 4. Input these values into the questions equation. And first of all, before inputting, I was just about to forget, we have to find the value for y for each of these questions. So y is equals to x plus 4. 5 plus 4 is equals to 9. And second, 3 plus 4 is equals to 7. And minus 4 plus 4 is equals to 0. So we have three sets of pairs. So 5, 9 is the first coordinate. And then we have 3, 7. And also we have negative 4, 0. For those of you who don't know, the left side in the graph in this coordinate bracket is for the x-axis, and the right side in the bracket is the y-axis value. So that's it for part A. In fact, we can also we should also check if either of these values are incorrect, and for that again we have to input it into the question. So 5, we have 9, so 9 is equals to x squared. We have 5 for that. 5 5 is 25, minus 16 is 9. So this is correct. One coordinate is correct. For the second coordinate, we are going to say that 7 and 3, and we are going to change the values of y and x according to the coordinate we input. If we just input the y value of 9 and input the x coordinate to be 3, the value is going to be different. It's going to be wrong. So for different coordinate values, use the same x and y coordinates which are in the bracket. Okay. So y is equals to 7. So 7 is equals to 3 squared minus 16. 3 3 is 9 minus 16 is equals to 7. Oh, the second coordinate is also correct. Wait a second. Yeah, it's third value, we have the y value to be 0. 0 is equals to 4 4 is 16 minus 16. Yes, 0. So the third coordinate is also correct. For part B, we have y is equals to x, and 3x minus 2x squared is equals to y, or 3x minus 2x squared is equals to negative y. And what we are going to do is again switch the value, so which will become y is equals to 2x squared minus 3x. Okay. We have two possibilities of y. Input these, put equation, we will say this is equation number 2, this is equation number 3, and this is equation number 1, which is quite simple. So put 1 into 2. Okay, so we will say that minus 2x is equals to 3x minus 2x squared. Okay, so we will get 2x squared minus 3x plus x. So minus 3x plus x is basically minus 2x. So it's going to be 0. Again, if we just input this quadratic equation into the calculator, we will get x equals to 1 or x equals to 0. Or the second thing is put equation 1 again to equation 3, and that will give us x 2x squared minus 3x is equals to x. And 2x squared minus 3x plus x is minus 3x minus x equals to minus 4x is equals to 0. And which if we just input this value, we will get x is equals to 2 or 0. And let me erase the board here. And what we'll get here is, when we have to input these values. Oh. Okay, so input these values into the question itself. We will get, we will get first, sorry, we have to find the y values. So y is equals to x, we have 3x values, so we will have coordinates equal 1 1, 0 0, and 2 2. That's it. Now just input these values into the question to check if they are correct or not. So is y1 is equals to 3 multiplied by 1 minus 2. So 3 minus 2 is 1. So which is correct. First part is correct. 0 is equals to 0 minus 3 multiplied by 0 is 0, minus 2 multiplied by 0 is 0. So 0 is equals to 0 in a model. So the second value is also correct. For the second, we have 2 is equals to 3 multiplied by 2 is 6, minus 2 to the 4, 4 multiplied by 2 is 8. So we have 2 is equals to negative 2, but in a modulus, so that solves the problem, and that is correct. So these three values of these three coordinates are correct. So that's it. Last question is part C. Okay, for part C, we are having y is equals to 3x, and the second equation is y is equals to 2x squared minus 5, but in a modulus function. Y is equals to 2x squared minus 5 in a modulus. So again, two possibilities: 2x squared minus 5 is equals to y, or minus 2x squared plus 5 is equals to y. I've told you already how negative y should become positive, and that's why this is taking the negative sign, which was to be assigned to y. Okay, so on to that, just simplify these equations. Input the values of the second equation, assuming this is equation 1, this is equation 2, and this is equation number 3. So put equation number 1 into equation number 3. So I don't know why I did 3 first, but still, minus 2x squared plus 5 is equals to 3x. Okay, and what we are going to do is simplify 2x squared. I told you why negative 2x squared, the x squared coefficient should always be positive no matter what. You have to change the whole equation, change it. Just make the coefficient of x squared a positive value. 2x squared minus 3x, plus 3x minus 5 is equals to 0. Okay, and just input this into the calculator, and you will get for this specific equation x is equals to x is equals to negative 2.5 and 1. Okay, x equals to negative 2.5 and 1. And the second equation, put equation 1 into 2. That will give us 2x squared minus 3x plus 5. I've just done it directly, so is equals to 0. So simplify this, put this into a calculator directly, and we are going to get x is equals to 2.5 and negative 1. So 4 values again. We have to input all, first find the y-axis for all of these values. So just use the calculator to make it really fast. So y is equals to 3x. 2.5 multiplied by 3 is equals to 7.5. To 2.5 and 7.5 will make one set. The second set will be made minus 1, so minus 3. Okay, we will say x equals to minus 1, so y is equals to minus 3. The third value is minus 2.5. So minus 2.5 multiplied by 3 is minus 7.5. So minus 2.5 will give us minus 7.5. And at last, the fourth value will be positive 1. So positive 1 will give us positive 3. Now we have to check which of these values are incorrect and which are correct. So 7.5, is it equals to 2.5 squared multiplied by 2 minus 5. So Yeah, it's equals to 7.5 in a modulus. So this is correct. The first part is correct. The second one, negative 3 is equals to negative 1 squared is 1, multiplied by 2 is 2, minus 5 is equals to negative 3 in our modulus. So this one is actually incorrect because out of a modulus we can't get a negative value. So this is incorrect. Incorrect. Third value we are having minus 7.5 and minus 2.5. Again, this will be directly not correct. So it's going to be minus 7.5 is equals to 2 multiplied by minus 2.5 squared. Sorry, wait a second. Minus 2.5 squared, which gives us 6.25 multiplied by a 2 and subtract it from 5, so which gives us 7.5. Again, the modulus, I told you at first, we cannot have a negative value out of a modulus. Either it's negative or positive, we do not care. But still, this on the other hand, there is a negative value. So this is incorrect. This one is also going to be incorrect. For the last set of values, we have 3 and 1. And what we'll do in this case is 3 is equals to 2 multiplied by 1, 2 minus 5. So that will give us negative 3 in our modulus. But this negative 3 is in a modulus which will become positive. So which means this value, this one is correct. So 1 and 3 are correct. So in the end, we have got the answer to be is equals to two coordinates, 1 and 3 and 2.5 and 7.5. That's it for exercise 1.4. Thank you, and I will meet you in the next lecture.